So let's talk for a minute about what it's going to take to analyze these data in order to make equal potential graphs. If you look at the plot on the right, this should be what your IOLab data screen looks like after you've taken 4 runs of data. And you'll recognize, similar to your data, that every moment where you had the probe lifted, you find that you get a noisy value around 1.5 volts, which is about half the battery voltage in your IOLab device. But when you were contacting the paper, you get flat lines. And the reason we have 4 flat lines set up parallel to one another is that we took 4 different runs. Now, if you focus on the top of your IOLab, in the center you have 3 optional buttons that you can use to select your data. One that you're fairly familiar with at this point is the zoom button, which has 3 options. That is zoom by a rectangle, zoom only on the horizontal axis, and zoom only on the vertical axis. And also is the 3 sets of bars. The 3 sets of bars allow us to analyze the data itself, and that's what lets us select a highlighted region. In this particular data set, you'll see that the mouse has been dragged over this region where it has turned a beige shade and a reddish shade below. And because we have 4 runs collected here, we get 4 sets of analysis data. Now, please don't pay attention to these numbers on the left. They happen to be corresponding to where the cursor happens to be sitting at this time. These boxes to the right are the analysis of the data within the highlighted region. Each portion of the region has a mean, it has a sigma, which is an error bar, an area which we don't care about, and a slope which we certainly don't care about. And so for this, the 1, 2, 3, 4, 5th measurement, we see that our numbers will be 0.284, 0.427, 0.643, and 0.577 for each of the 4 passes we made with the voltage probe. Therefore, in order to make the 5th column of measurements in my Excel sheet, I'm going to put exactly those values: 0.284, 0.427, etc. And as I continue on, I can fill in all the rest of the values. And then my spreadsheet looks like this, in that I have captured all of the voltage values at each of the locations where I made a measurement. Now we need to plot this data. And to do so, what we're going to do is highlight the data itself, go to the Insert menu in Excel, and up here, this thing that looks sort of like a spider web is the thing that allows you to make surface forms of plots. And what we're going to begin by making is a surface plot. So there it is. This is the surface plot of the voltages that we made. It's already kind of pretty. I'm not going to tell you what kind of a configuration this data was from, but I'm betting that looking at the figure itself, you can guess. However, in order to make it more quantitative, what we want to do is we want to control the locations where the color changes. And to do that, what I'm going to do is right-click on the chart itself. I'm going to choose Format Chart Area, which is going to bring up a series of menus on the right-hand side. Now, I'm not actually interested so much in formatting the chart area as in deciding how the colors will change. And so in order to address the colors, which are the vertical axis of my plot, I'm going to select the vertical axis menu. This bar-like symbol are the options for the data itself, and when I choose axis options, I'm going to be able to set the minimum and maximum values. Based upon my data, going from 0.2 to 0.7 looks pretty good, and I think I will set the major ticks to be of a value of 0.05. Once I click outside that box, you can see that I get an absolutely gorgeous surface plot showing the potential, and you can now clearly see that this data corresponds to a small place of high potential and a large place of low potential, and that should give you a hint what the configuration of metal was when this data was taken. In order to get another view of the data with the chart itself highlighted, I'm going to type Control-D. That will make a second copy of the chart, and then on this menu here I'm going to change the chart type to a contour plot, select OK, and now my second plot is a contour representation of exactly the same data. Each of the colors is a different equipotential value, and the legend at the bottom here tells you the potential represented by each color, and we're going to use that information to figure out electric fields by figuring out the rate at which potential changes with distance.